Hello, and welcome to another Keep Talking and Nobody Explodes module tutorial. Today I am going to be taking a look at Off-White Cipher. This module is a cipher module, but with a twist on it. First of all, if you press the left or right buttons, you'll see they kind of disappear and typing doesn't really do anything. So what happens when you press submit, that is, the module transforms into a grid that all can be colored with the original display and a submit button. So you can color the grid however you want, and we need to color them in a specific way. So first of all, let's note down our screens and begin the deciphering process. Whiskey Bravo Victor, Alpha Alpha Delta, Hotel Romeo Quebec, Oscar, and 112. So, first of all, the first cipher is Composite Spinning Jumping Leapfrog Orphanage Cipher. It's very important that you memorize the names because they actually have a lot to do with the modules themselves. So, this is the first step. What we have to do is modify our orphanage. This is the orphanage, and we must accept some children into our orphanage. Every time we accept a child into our orphanage, it gets modified a little bit. So the first child we're gonna enter into our thing is gonna be the first letter in our 4-digit number or letter thing, and then after that we're gonna apply the second letter, then the third letter, and so on. So, how do we actually accept these kids into the orphanage? Well, we look at the first letter, which is a representation of their full name. So if we find H, that's Hilbert. So H stands for Hilbert, R stands for Rogers, Quebec stands for Queen Elizabeth II, Oscar stands for Orphanius. Now, the way we accept these children into our orphanage is that we take the squares colored gray and we're going to turn them 180 degrees clockwise. So, this means that this would go here, this would go here, this would go here, and this would go here, and so on. And we do that in our orphanage. So, we would do Romeo, Mike, Hotel. Or let me actually do the one down here. Yep. We would do Romeo, Mike, Hotel. Then we do Foxtrot, Kilo, Papa. The Lima stays the same because it doesn't actually move. So you can see FKP, RMH. And that seems to be a 180 degrees turn. We then copy this, and then we accept the next child into the orphanage. So the next child is going to be Rogers. We're going to turn this 180 degrees around. So K, M, G, Q, H, P. Now we're going to accept Queen Elizabeth II into our orphanage. We're going to take Yankee Sierra November. She does not get any special privileges. Romeo Kilo Papa. Like so. Then we're gonna accept Orphanius into our establishment. Then, after we've accepted all of these wonderful, wonderful children into our orphanage, we are gonna prepare ourselves for the composite spinning, jumping leapfrog part of the cipher. So, first of all, we need our 6-character string, or encrypted string up here, and we need to split it into 3 pairs, each with 2 letters, like so, and then we're going to jump over it. The first letter is going to jump over the second, so here in this example, Kilo jumps over Echo. So to get from Kilo to Echo, we have to go right, up. So from Echo, we go right, up. which lands us there. So we simply do the same movement that we need to do to get from the first letter to the second, from the second to whatever the letter is. And then we take our second letter with the letter we got in step 1 that's decrypted. So Whiskey over Bravo in our grid requires us to do right, right, up, up. From Bravo, right, right, up, up is a kilo. Then from Bravo over Kilo, that's going to be up, up, left, left. Up, up, left, left, that's a Quebec. Victor over Alpha, that is going to be a down, left. Then from Alpha, we're going to go down, left to Juliet. Then Alpha's going to jump over Juliet to get right or left down, which is Romeo. Alpha over Delta is going to be right, 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 which is Bravo. Delta over Bravo is going to be left, 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 which is an Echo. This is our decrypted string. Now we can move on to step 2, which is McDonald's Chicken Nugget Big Mac cipher. For the McDonald's Chicken Nugget Big Mac cipher, we need our 3-digit number from the last screen, which is going to be 112. And we're going to have to do a little bit of math. So, we need to see how much money each of our, how much money we have for, because we can buy 3. How do I say this? We need to get 3 orders. And the way we need to see how much money we have is to do some little bit of multiplication. We're going to take our first number here times 676. So 1 times 676 plus the first letter, which is that is going to be 11 times 26 plus the last letter, 17. If it's a Zulu, however, it's a 0. So then we take this and add it up, and we get the amount of money we have for this specific thing is this. We're going to do the same for the second one. 676 times 1 plus 10 times 26. Yep. Plus 18. Yep. Move this in here. 954. 676 times 2 plus 2 times 26 plus 5. That gives us this. 1409. And then with these numbers, we need to see how much of each order we can buy. There's a cheat to this, however, which will be listed down here. We take the price of the first item, or the amount of money we have for the first item, multiplied by 4, modulo 41. That's gonna be, or I'm gonna do it like this. Then we're gonna take this minus x times 31 divided by 41, like it says up here. The first step is to take our number times 4 modulo 41. That's going to give us our first letter in decimal. Then we take our first answer minus the letter we got from the previous step. Remember, these are still in 2 pairs. Divided by 41. And that is our second value, so we're going to do this. Pop it into text field. So that gives us 21 and 8. 21 is a uniform, and 8 is a hotel. We're then going to do the same, but this time with a different number. 3 and 21. Then we're going to do this with our last number. 19 and 20. ST. Is that really a word? Accust? I'm quickly gonna check if that's a word, because it might and or might not be. generated as a locust, which means our first number was wrong. So we're quickly gonna recheck our number. It is 676 times 1 plus 11 times 26 plus 17. That gives us 979. This means that we probably decrypted the letter wrong. So let's go back to this. Whiskey jumping over Bravo is going to be a right, right, up, up. Right, right, up, up. That's a kilo. Bravo over kilo is going to be a right, right, up, up. Right, right, up, up. That's a Yankee. I think what I did is that I jumped kilo over Bravo. Let's see this. Down, down, left, left, down, down, left, left. Yes, that's what I did. I jumped kilo over when I wasn't supposed to do that. What we're gonna do is we're gonna take our now correct thing and redo it. So 676 times 26, or times 1 plus 11 times 26 plus 25. That's gonna give us a new number, which is 987. 987 and 987. That's gonna give us 12 and 15. So 12 and 15 are of course going to be Lima and Oscar, which is going to give us a locust. Now, with this word, we can begin the last step, which is to begin the standard procedure of generating an NFT for money laundering purposes. So, to construct the NFT, we need to take our confidential string here, and we need to make 2 strings out of this. The first one is each letter modulo 10 individually. So Lima, 10 or 12 modulo 2, or just take the rightmost digit. So it's going to be a 5, 3, 1, 9, 0. Just by taking the last digit. This is our first string. Our second string is going to be all the letters multiplied by each other. 15 times 13 times 20 times 21 times 19. And Lima, which is times 12. That is 430920. Let's see if this is 12 digits long, as per normal. This is actually 1 digit too long, so we can destroy the last digit. It has to be at least 12 digits long. Or, yeah, it has to be at least 12 digits long. So, let me make sure I did it correctly. 12 for Lima, yep. Times 15 times 3 times 21, 8, 19, 20. 21, 19, 20. Yep. So we're going to move this last digit. And both of these should be 12 digits long. Then we're going to split these into a few groups. We're going to take the first one, the first 3 characters, and put these in the table. So 2, 5, and 3. These are going to correspond to the colors we're going to use. Then the next 8 bits are going to be our coordinates. And then the last bit is something else. So, first of all, we're going to fill our entire grid with color 1. Color 1 is green. Gonna fill the entire thing with green. Alright. Now, we are gonna find coordinate 1 and coordinate 2. The coordinates have to be between 1 and 6. So we have to add or subtract 6 until it's within 6. 1 and 6. So it's going to become a 3. It's going to become a 3 as well. So now it is by column then row, I think. Yeah. Column then row. So we're going to find 1. And then 1, 2, 3. This is our first coordinate. And then 6, 4, which means these are our 2 coordinates. we're going to form a square of these two coordinates, and we're going to fill this entire square with color 2. Color 2 is white, so all of these are going to be colored white. So 1, 2, 3, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. Yep, that seems correct. Then we're going to do the same for coordinates 3 and 4, and with color 3, which is red. So 1, 2, 3, 6, 1, 2, 3, 1, 2. That's going to be, these are going to be filled with red. And then we're going to get our last digit, and then we're going to invert any color that is on the gray section. So green becomes magenta, red becomes cyan, black becomes white, yellow becomes blue. So for this entire row, this is going to become magenta for all of the ones on even rows. Whoops. All whites becomes black. Reds becomes cyan. And then once we have our NFT generated, we can sell it on the black markets for Ethereum. Alright, so as it turns out, I actually inverted the section that I was not supposed to, as this is on an odd column. So that does not need to be inverted. Now, we can sell this on the black market for hopefully many Ethereum. Let's see how many we make. 3,000. That was a nice value. That is how you do off-white cipher. Thank you for watching, I guess.